Now we're going to be graphing from standard form. So we're going to be able to pull a lot of things we've already talked about together and see how they fit together, see them in different ways. So since we're familiar with standard form, I'm going to start by kind of talking through its parts, and we'll list some of the steps, and then we'll jump over to an example and then jump back. So standard form, just like it was before, so now it's going to be a graph, so we're going to see it with a y instead of a 0, but ax squared plus bx plus c. And so our steps are going to be the same to start with. It's going to be step 1, list a, b, and c. Step 2, start thinking about what those a's and b's and c's tell you. You know what A does. A does the same thing. A gives you a rough sketch, right? I want you to start doing that actual rough sketch. When we're doing vertex form or intercept form, it's not a big deal to do the rough sketch because it's so quick to actually do the graph. But now we're going to have some math to do in between. And so I want you to think about if A is, positive or negative, big number, small number, what does it do? Is it going to be a shrink? Is it going to be a stretch? Is it going to open up? Is it going to open down? So A is going to give you the rough sketch, and C is going to give you the y-intercept. The y-intercept is always 0, C. So you're already going to be able to start placing things in the graph. And then you're going to start doing some math to get your axis of symmetry. So axis of symmetry has an equation associated with it. We know axis of symmetry lines are going to be x lines, and I probably write it slightly differently than you'll see it in a book because I struggle with negatives sometimes. So negative b over 2a. If you see it in a book, it's probably just going to say negative b over 2a, but sometimes I forget the negative when it's like that. So I like the parentheses. They help me remember various facts about how the axis of symmetry comes about when you look at the equation. I'll probably say more about that later. Okay, so I'm going to take us this far. Step 4 on how to find the vertex, I want to wait till after we do an example. So you can see how much room I have here. I want to start doing the example, and then I'll go back and I'll finish the steps, because I think it'll be more clear when we have an example. And it's an example, we might have even seen this exact graph before. Let's start with y equals x squared minus 2x minus 8. So a lot of times we'll start with ones with an a of 1. They're the easiest kind. And hopefully you've started to recognize a pattern with ones that have a as 1. They're going to be the most common, but you have to still know how to do all the steps. So we're going to start by listing a is 1, b is negative 2, c is negative 8. So we know that it's going to be kind of a normal width because a is 1. It's going to open up, and our y-intercept is going to be negative 8, 0, negative 8. So we can start graphing that already. There we go. And then we're going to find our axis of symmetry. It's going to be x equals negative b over 2a. b is negative 2, a is 1, so negative, negative 1, so x equals 1. So our axis of symmetry is going to be right here. And some of you may already remember, since the y-intercept is so close to that axis of symmetry, you might already know that vertex number. To find the vertex, what we're going to do, think about it. What do we know about the vertex? The vertex sits on the axis of symmetry. So that means we know the x value of the axis of symmetry, the x value of the vertex is the axis of symmetry number. How do we find the other number? We find the y value by plugging in axis of symmetry number to the original equation, right? This number is this number, and it goes here. And then we just do the math, and that'll get us the y value. Remember, a function, we can plug in any x value, and it'll crank out a y value. It'll be a unique y value. So we know that when x is 1, that's going to be on the axis of symmetry. It's going to have to be the vertex. So we just do the math. 1 squared is 1, negative 2 times 1, negative 2, minus 8, negative 1 minus 8, negative 9. So our y value of our vertex is negative 9. So, oops, I graphed negative 7. Negative 8. I'm falling off my graph a little bit, but negative 9. So that's our vertex, so we know that the mirror image point is going to be on there. And now we could do a rough sketch and be done, but what I want you to do is check if it's factorable. So I'm going to jump over first and finish our steps over on the list of steps. How did we find the vertex? We substitute the value of the axis of symmetry into the original equation. Right? That gets us the y value. Find vertex y value. Because we already know the x value, that's the axis of symmetry. All right, so after we do that, step 5 is graph, including max or min, possibly domain and range, and then including, if factorable, give me the x-intercepts. So now I'll look back at my example problem and say, is that factorable? And a times c is negative 8. Things that multiply and give me negative 8 add up to negative 2. It's going to be x4. Okay, I can do all this in my head, and you're going to trust me that this is going to be y equals x minus 4, x plus 2. If I substitute a 0, I get this. It's just factored form, just like we did in the last video, intercept form. So my y-intercepts are 4, 0, or x-intercepts are 4, 0, negative 2, 0. So my x-intercepts are 4, 0, and negative 2, 0. So now I have lots of information to graph the parabola very accurately. Okay, so domain would be all real numbers, range would be y is greater than or equal to negative 9. Our x-intercepts, we've got 4, 0, negative 2, 0. Our y-intercept is 0, negative 8. Our vertex is 1, negative 9. It's a minimum of negative 9 when x equals 1. So there is a parabola where we can do everything. Now if it's not factorable, you can just estimate the x-intercepts. Again, sometimes you might not have x-intercepts. Sometimes you might have one x-intercept. Sometimes your y-intercept won't be on the graph and you won't be able to graph it. That's okay. You can still tell me what it is. All right, second example. So we've got negatives this time. We got a equals negative 2, b equals negative 8, c equals negative 3. So our y-intercept is 0, negative 3, and we know it's going to open down and be rather skinny. It's going to be a stretch. Right? It's going to be narrow. We could start graphing our y-intercept. We can find our axis of symmetry. X equals negative b over 2a, b over 2 times a, so negative 8 over negative 4, positive, positive, so it's going to be negative 2. So x equals negative 2, and then we're going to find our vertex by plugging that number in. It's going to be negative 2 something. It's a function, so we're going to plug in the value to find the y value. So we've got y equals negative 2 times x squared minus 8 times x minus 3, and we're going to plug in our x value that we got for the axis of symmetry into both of those x spots. Now we got to be really careful about our order of operations. We're squaring just the x. So we're going to have negative 2, which is the front one, times 4, which is negative 2 squared. And I can go ahead and do these now. Negative 8 plus 16 minus 3, 8 minus 3. So we get positive 5. My other arrow there wasn't very good, was it? It went there, and this one goes here, because that was our y equals. Okay, so there's our vertex. So negative 2, 5 is way up here. Let's get our x axis of symmetry in place. Negative 2, 5 is way up here. Look how far apart our y-intercept and our vertex are. We know it's a maximum. We know it opens down. We know that if that's 2 points away, that's 2 points away. Is it factorable? Is there anything that multiplies and gives me 6, negative 2 times negative 3, and adds up to negative 8? Nope, not going to happen. So you don't need to do it. You can estimate based on the fact that, you know, this is a mirror image, and I didn't flip the iPad around, so that was not very pretty. Oops, that's not an eraser. There we go, that's not horrible. And so our y-intercept we know for sure is 0, negative 3. Our vertex we know for sure is negative 2, 5. We know it's a maximum at positive 5 when x equals negative 2. And again, the x-intercepts we could estimate at about negative, I'd say 1 1/3 and probably negative 3 2/3. That'd be my guess, but I'm not going to write it in. If push came to shove, I would write it down. But so there's one where you don't have to factor, or you couldn't factor, so you don't have to have the x-intercepts there. Let's do another more basic one. Let's do y equals So when you're thinking about your recap, when you're writing your summary on the assignment, make sure you think about how all the parts fit together. What parts of it are like vertex form? What parts of it are like intercept form? What parts did we take when we factored? How do all these little parts all fit together?